Hello, and welcome to Lessons with Laurie, where we talk about some of the big ideas in mathematics, kindergarten through grade 5. And in this lesson, I want to think about a current topic, that being the 6-foot distance that we're supposed to keep from other people. And as businesses are starting to reopen, they're challenged by that problem of how do I actually ensure that my workers or that my customers are at a safe 6-foot distance from one another. What does that model look like? Well, we know that we want to have 6 feet on either side of us and front and back, but also all the way around us. So a model we might use would look like this. If I'm at the center of this circle, it means my radius here needs to be 6 feet to make sure that anyone that is near me stays a safe 6-foot distance. Well, the rest of the story is that we know other people are involved. So here's a model of 2 people side by side. As a matter of fact, it could be myself and my girlfriend. We actually walk on rural roads here where there's no traffic, and so we don't have to worry about cars. So if I have a 6-foot distance and my girlfriend has a 6-foot distance for our radius, you can see that the distance between us then is actually 12 feet and not just 6. So the radius of our circle only needs to be 3 feet in order to keep that 6 safe foot distance between us. Well, I'll tell you, the reality is that there's more than just 2 of us that are walking. There are more than 2 people in the supermarket. There are more than 2 people in an office building. So if we all had a 3-foot radius around us, it might look like this. So is this what businesses are thinking about as they're trying to reopen? Is this the model that's in the back of their mind? Because one of the things that you probably notice about this particular model is that there's this gap in the middle, that circles do not do a very good job of covering an area. And if I shift it a little bit, you notice that that space in the middle actually gets minimized. It's smaller, but there's still a gap in the middle here. Well, that's actually an area of mathematics that is pretty important, and it has to do with modeling, that when I pack things, keeping that 6-foot distance, if I pack things in this fashion, in a rectangular fashion, you can see that there's a gap here. If I shift those circles, the gap is reduced, it's minimized here, but there is still a gap. Actually, honeycombs, our honeybees know something about this because they know that when they make their honeycombs, they're actually done in the fashion of a hexagon. So you're minimizing the space, the gaps that are in here. So that's one model, a circular model, but it's not an efficient one, and it's certainly not how we actually measure area. So businesses who are looking at the square footage of their office space or their business know that they need to be working with square units, not circular units. That's why we use squares to measure the attribute of area. So when I put 2 of them side by side, they do indeed pack nicely without any gaps in between. In mathematics, we start to look at the concept of area in 3rd grade. So here's a model. I'm using inch tiles, 1 inch by 1 inch. Inch tiles in order to form this rectangle right here so that I can talk about the area of this rectangle as being 1, 2, 3, 4, 5, 6. It has an area of 6 square units. And because my unit here is an inch, I would even say that it's an area of 6 square inches. Notice that the dimensions are 2 by 3. Well, that has to do with multiplication, of course, and when students are in 3rd grade, we actually start to talk about multiplication as an array. I have 5 rows here, 7 columns, so we talk about the product, 5 by 7 being 35. Well, in terms of my rectangle right here, we know that our dimensions, length times width, will give us the area of this rectangle. So our businesses are working with the square footage of their particular workspace. Notice I switched to square feet. Well, here's a model of a square foot. I actually taped together just 4 rulers. So this is what a square foot looks like. This is what a square inch looks like. Notice that there are more than 12 square inches in a square foot. As a matter of fact, there are 12 by 12 or 144 square inches in a square foot. So businesses are thinking about the square footage that they have and how they can safely implement a 6-foot social distancing challenge as they open up. So here's area. A related topic is about perimeter. So I have some pieces in front of me that I refer to as perimeter pieces. I've actually cut these so they're 1 inch long, these perimeter pieces. And if I take 6 perimeter pieces, meaning 6 inches, and form a rectangle with them, this is what it would look like. So here's a rectangle that has a perimeter of 6 inches. Here's a rectangle that has an area of 6 square inches. The difference in those units, square inches versus inches, perimeter and area, distance around versus a covering process. When we talk about perimeter and area in the classroom, we like to use actual physical models, and then we transition to grids. Now, if I'm going to work with area, I want to have square grid paper in order to do that, so students can literally put their fingers on each one of these squares and count. If I'm going to work with perimeter, I actually like to use dot paper so that students are tracing between the 2 dots as they form their figures. So they're literally counting how many of these segments am I drawing. So what can you do with perimeter and area at home? There's a really interesting problem that, again, is part of our curriculum that asks the question, is it possible for 2 rectangles or 2 polygons even to have the same area but a different perimeter? Conversely, is it possible for 2 rectangles or 2 polygons to have the same perimeter but a different area? And the answer to each question is yes. So here's a picture of 3 different shapes. 2 of them are rectangles. This last one is simply a polygon made up of straight line segments, as you can see, that are closed in. Each of these has an area of 8 square units, but they each have a different perimeter. Here are 2 shapes that have a perimeter of 8 units, but they have different areas. This has an area of 4 square units. This has an area of 3 square units. So investigate area and perimeter by cutting out some square tiles out of heavyweight paper. You can print grid paper online. Cut some plastic straws or little strips of paper or wire in order to have perimeter pieces so you can investigate perimeter. But also think about perimeter and area in the context of your day-to-day life. I mean, if you're walking around your community, as you're walking around your neighborhood block, talk about perimeter. You're walking the distance around it. Or if you're walking around the track at your local YMCA or school, you're walking a perimeter, a distance, a linear distance. Also talk about area when you're trying to cover something, whether it's putting placemats down on your table at night, you're covering that area, or even when you're putting those pepperoni slices on that pizza, you know that those little pieces of pepperoni do not do a good job of covering because they always leave that gap. Talk about those concepts and ideas with your children. Thank you for being with me. See you again next time.